Hello everyone, and welcome to Group 13's presentation for Lab 5, Latches and Flip-Flops. Our team consists of Timothy Johnson, Alec, Mateski, and Kevin Davis. The purpose of these slides is to become familiar with SR latches, as well as gated D latches and D flip-flops, being able to read and understand a data sheet, and read and implement a transition table. Transition tables, unlike truth tables, do not only account for the current inputs of a circuit, but also the previous output. This is a typical transition table for an SR latch. You will notice at the bottom that some of the outputs are labeled NA, as they are not typically used. In an SR latch, you will not be both resetting and setting the circuit at the same time. Here we have a Logisim circuit for a NOR SR latch. Figure 1A shows a working representation of the circuit in which it has a bistable state, so it has two states that work, both set and reset. In figure 1B we see the unused inputs where both set and reset are set to on, and that results in no outputs. In figure 1C we can see that before the SR latch is initialized you get an error state. A NAND SR latch, similar to a NOR SR latch, is a bistable circuit, meaning it has two stable states of set and reset. A NAND SR latch can only change states when one of the inputs is off. When both of the inputs are off, you get both outputs being on. In a gated D latch, the inputs are controlled by a gate. When the gate is off, the input will have no effect on the output. When the gate is on, toggling the D input will flip-flop the output. This slide simply shows the NOR, NAND, and gated D latches side by side so that you can observe the similarities and differences. This data sheet shows specifications for an integrated circuit. Looking through the information here, you can see a couple of interesting points which we are highlighting. Things like the maximum clock frequency and what to expect when changing the inputs. Marked as PLH and PHL, you can see the maximum time that will take to clear, clock, and set to output. Both low to high and high to low. At the bottom we see setup times and clear set times as well as hold times for this particular circuit. Here we have a GIF of a D flip-flop. When the enable is on, the clock will flip-flop the outputs at regular intervals. When the preset is on, regardless of whether or not the enable is on, it will always output a 1, and when the clear is on, regardless of whether the enable or the preset is on, it will always output a 0. In conclusion, we see that SR latches, gated D latches, and D flip-flops are essential in creating memory that can be used by the ALU to perform various computations. Data sheets provide useful information on how to implement an integrated circuit and let us know what to expect, especially in terms of timing. And transition tables are truth tables that account not only for current inputs, but also previous outputs. Thank you for watching.